And here's 3-2 of your textbook, using algebraic methods to solve linear systems. We're going to look at a few examples that will be able to help you out on your homework or classwork tomorrow whenever I see you next. Alright, so to use substitution, what you're trying to do is get one of your equations in your system equal to a variable, and then you're going to substitute that into the other part. So you can see this when we have y equals x plus 2. Well, we can substitute this x plus 2 in for the y. So the x plus 2, there's our y that we got from the other part, equals 8. So then we have x plus x is 2x, and then plus 2 equals 8. If we subtract 2, we'll get 2x equals 6, and then divide by 2, you get x equals 3. Then to get the y value for our solution, we can just plug that back in to either one. It doesn't matter which one. I'm just going to pick this first one since it's already solved for y. So y equals, here's my 3 instead of the x that was up here, plus 2. So y equals 5. Therefore, my solution is 3, 5. Okay, here's the next one. So this one isn't quite as easy as the previous one, as it's not solved for a variable yet, but it doesn't matter which way you choose to do this. In fact, your book shows you two different ways. You could solve one for x or you could solve one for y. Totally does not matter. So we could choose, say I picked the second one and I solve it for y. I add 8x over to the other side, so I get y equals positive 8x plus 1. And then up here, I'm going to have 2x plus y equals 6. So this is my, it's not new, but rearranged a little bit. So I have this 8x plus 1, and I'm going to plug it in for that y. So I'm going to have 2x plus, here's my new y value of 8x plus 1 equals 6. 2x plus 8x is 10x. And we have plus 1 equals 6. If we subtract 1, we'll get 10x equals 5. And then divide by 10, we'll get x equals 1/2. Then to get our y, you can plug it into either one, but I'm just going to choose this one. So I'm going to have y equals 8 times our x value we solved for is 1/2, so we just got that from there, plus 1. Well, 8 times 1/2 is 4, then plus 1, y equals 5. So my solution here is 1/2, 5. Again, you could have taken this back and you could have done, originally you could have solved for x and then subbed in for x on the other one, but I just picked y. You always choose the one that you see first, so that way you can get through the problem. Sometimes it's easier to solve by substitution, but sometimes it's easier to solve by elimination. In this case, elimination is going to be easier because you can see it's already lined up in order. Notice we have the x's in the first column, the y's in the next column, equals our constant in the third column. And this one is already nicely set up for us because if we, I'm just going to rewrite this right here, whoops, 2x plus 3y equals 34. And 4x minus 3y equals -4. So elimination, your goal is to look for, if I add things vertically, what will allow something to cancel out? Well, in this case, if you notice, this plus 3y, if I'm adding these things together, going straight down, those will cancel each other out. So 2x plus 4x is 6x, and then positive 3y plus a negative 3y, those cancel. That's just 0. Equals 34 plus -4 is 30. Then we can just divide by 6 on both sides, and we get x equals 5. Then just like we did before, we go back and plug it into one of the equations. So we could try this one. It wouldn't matter which one, you'll get the same answer. So 2 times our x value that we got is 5, plus 3y equals 34. So then if that's 10 and I subtract it over, I'll get 3y equals 24. And then divide by both sides by 3, I get y equals 8. So I've got my x, I've got my y. My solution is 5, 8. Here's another example of using elimination. But this one isn't perfectly set up for us yet. Notice that if we were to add things vertically, there's nothing that's going to cancel each other out yet. So sometimes we have to multiply. So for this one, you could choose to make it your goal to cancel out the x's or the y values. It doesn't matter. But let's just go for the x's in this case. So I'm thinking, what can I multiply 2 by and what can I multiply 3 by? So that way I'm going to make it easy on myself, so that way I can cancel something out. So let's try if we multiply this top thing by -3 and this bottom one by +2. Watch what happens. Okay, so -3 times 2, that's -6x. -3 times 4 is -12y. And then -3 times -10 is +30. On the bottom, we're multiplying everything by 2. We get 6x. And then plus 6y equals -6. So now, adding these straight down, -6 plus a +6, that cancels each other out, which is exactly what we wanted to do. -12 plus 6 is -6. So we have -6y equals. And then 30 plus a -6 is 24. Now we can divide both sides by -6 and we get y equals -4. Then to get our x value, you can just go back and plug it in. So if we say we did it in the second one, if we have 3x plus 3 times -4 equals -3, well, that's just -12 right here. So I'm going to add that over to this side. So I have 3x equals. So -3 plus 12. We get 9. Whoops, 9. And then divide both sides by 3 and we get x equals 3. So then here we get the solution 3, -4. Now I hadn't mentioned it yet, but we do always have to go back in and make sure that if I plug them back in that they work. So we're going to go back to using the verify solutions, just like we did in the video 3-1. And so what you'll want to end up doing is setting up a table for each one if you'd like. But we're just plugging back in the x and the y. So 2 times 3 plus 4 times -4. And this is just to check. So here I get 6 plus -16. I get -10 equals -10, and that one works. And then, of course, you have to do the other one as well. 3 times 3 plus 3 times -4 equals -3. So we have 9 plus a -12. We get -3 equals -3, and that works again. So it turns out this is actually a good solution. If it didn't work, then we couldn't include that, and we would say no solution. So always make sure you're going back and plugging them back in to check your answers. Okay, now we're going to classify the system and determine the number of solutions. So because isolating y is pretty straightforward in this first one, let's go ahead and solve this for y, and then we can use substitution. Another option would be you could multiply and then use elimination, but it's up to you if it doesn't tell you. So if I solve this one for y, I'm going to get y equals -2x plus 8. So then I can substitute -2x plus 8 in for this y right here. So I'm going to have 6x plus 3 times -2x plus 8, that's our y, equals -15. Then I just need to simplify and solve for x. So I'm going to have 6x and then minus, so we have 3 times a -2, that's a -6x. And then 3 times 8, 24 equals -15. Well, these cancel each other out, right? The 6x minus 6x, that's just 0. So then we end up with 24 equals -15. Does that even make sense? No, it does not. So it doesn't work because 24 is never equal to -15. Therefore, it has no solutions. Now, because it has no solutions, That means it is inconsistent, because consistent means that it has to be at least one solution, but inconsistent means no solution. And that's it. That's what we're looking for. It says classifies, we inconsistent, and how many solutions? There's no solutions. And then we have one more example, and that's just this application problem. So we have a zookeeper needs to mix feed for the prairie dogs so that the feed has the right amount of protein. Feed A has 12% protein and feed B has 15% protein. How many pounds of each does he need to mix to get 100 pounds of feed that is 8% protein? So first of all, let's go ahead and define our variables. Anytime we are writing equations ourselves, especially with application problems, we need to define these variables. So I'm going to say that A represents the amount of feed A, and like that would be in pounds. And then B would be the amount of feed B. It's just the same thing, little ditto marks there. Okay, so now we need to write a system of equations. In one part we need to talk about the amount of each, so the total weight of the mixture, and then in the other we need to talk about the protein. So if we know we need 100 pounds of feed, then the amount of A plus the amount of feed B should equal, since these are both in pounds, our 100 pounds. And then for the other one, feed A has 12%, feed B has 5%, but we're looking for an 8% mixture. So if feed A is 12%, that's going to be 0.12 times however many pounds of A, plus B was 5%, 0.05 times the number of pounds of B, and then our percent mixture is going to be 8%, so that's 8% times 100. So let me explain this to you again. So notice the first number is always our percentage, and then the A, B, and the 100 represent the amount in pounds of how much of the mixture. So we have a percent times a pounds, percent times a pounds, percent times a pounds. So we can simplify this here as just equal to 8. So now that we have this system of equations, A plus B equals 100, and we could go ahead and make this other one a little bit easier on ourselves. It's totally okay to multiply here. If you don't want to deal with decimals, that's cool. Here we can fix that by multiplying by 100. Multiplying by 100 here, we'll get rid of these decimals, because 100 times 0.12 is 12, so then we have 12A. 100 times 0.05 is just 5, and then 100 times 8 is 800. That step is not required, but it makes it easier if you get a little stressed out looking at those decimals. Now you can use substitution or elimination. It's up to you. If I just go ahead and solve this one, say for B, B equals 100 minus A, or negative A plus 100, either way, 100 minus A. Then I'm going to substitute that in for my B here. I'm going to have 12A plus 5 times 100 minus A equals 800. So I have 12A plus 500 minus 5A equals 800. 12A minus 5A is 7A, and then if I subtract the 500 over to the other side, I get 300. And then 300 divided by 7, you would just type that into the calculator, and A will be about equal to 42.9. So that's how much amount of food, or feed A we would need. Then to get B, we could just plug that back in here. So then B will equal 100 minus the 42.9, that is A. So then B will equal 57, about 57.1. So we'll need 42.9 pounds of feed A, and then 57.1 pounds of feed B. And that's your answer. All right, that's it. Let me know if you have any questions the next time I see you, and I hope you have a great day. Bye.